Welcome. In this video, we're going to go over problems 2, 5, and 6 from page 16. That's the stoichiometry AP release. And looking at problem number 2, this is an example of a reaction where you have a solid that's a mixture. It's got strontium nitrate and potassium bromide in the solid. Okay, down here. Whoops, I got to turn my pen on. Okay, so I've got strontium nitrate. I've got KBr, they're in a solid. I'm going to dump in here some lead nitrate. And the key thing is this lead nitrate is aqueous, so really I'm adding water as well. And notice these two compounds are soluble. I know that because this is a nitrate compound, always soluble, alkali metal compound, always soluble. So I mix all these things together, really I'm going to have a bunch of ions. And I've got I'm going to have some lead ions, I'm going to have some nitrate ions, I'm going to have some strontium ions, more nitrates, some potassium, and some bromide. And of this mixture, the problem tells me I'm going to form a precipitate, and I know the identity of that precipitate. A lot of times when you're writing net ionic equations for precipitation reactions, sometimes it's easiest to start with what the product is. So if I know the product is PbBr2, and say, okay, what ions must have come together? Well, it must have been my lead ions and 2 bromide ions. So that is my net ionic equation. The molecular equation is actually not that important. I put that in there in case it helped you, but if you skip it, that's fine too. In general, you'll be asked for net ionic equation. Strontium nitrate, the strontium ions and the nitrate ions are just spectators. So they're not actually involved in the reaction. So it's asking me how many grams of KBr reacted. So you have to look at the problem and say, what do I know? So in this problem, I know that my original mixture here is 5 grams. I don't know the molar mass of this mixture, though, because I don't know what percentage is each thing. So I know it's got some strontium nitrate, some potassium bromide, but I don't know how much of each. I just know the total thing weighs 5 grams. So the only other value I'm given is that I have 0.7822 grams of PbR2. And I'm trying to find grams of KBr. So this looks like a stoichiometry problem. I'm going to go from grams of something to grams of something else. First step in a stoich problem is always to find moles. So let's convert grams PbR2 to moles PbR2. I lost my 2 there. And if I look up the molar mass, this one's going to be pretty heavy. It's 367 grams per mole. And then I know that every one PbR2, there's a couple different ways of approaching it, but let's look at our net ionic equation. I know that every one PbR2 requires 2 moles of bromide ions based on my net ionic equation. I want grams of KBr. So let's convert from, let's think about how many bromides there are per every KBr. Looks like every 1 KBr has 1 bromide in it. So if I find moles of bromide, that will tell me moles of KBr, and I want to convert from moles of KBr to grams of KBr, and then that will be, it's 119. So it's a stoichiometry problem, and this is actually, now I remember why I had you write the molecular equation. In this problem, you might, if you'd written out a molecular equation, that might make more sense in this context. You can think of it as lead nitrate and KBr making lead bromide and KNO3, and you will see that the lead nitrate and the KBr react in a 2-to-1 ratio, which we just showed down here. So the main thing is you need twice as many KBRs as you have moles of PbR2. So when you stop and solve here, you will end up with 0.5073 grams of KBr. And then what is the percent by mass of potassium bromide in the original mixture? So the way percent by mass works is you take the mass of the part, which in this case the part is KBr, over the mass of the whole thing, which is 5 grams. So the mass of the part is what I found doing stoichiometry. Okay, and the mass of the whole thing is 5 grams. And if you're thinking, why can't I just look at the periodic table to find percent by mass? Well, this whole thing right here, this is a mixture. We do not know the molar mass of this thing. It is undefined. All I know is I had 5 grams, And of that 5 grams, 0.5 of them seem to be KBr based on my stoichiometry. So that's all I know. So its big idea is you do not know molar masses of mixtures. They are undefined. This gives you 10.1% as your answer. So that's problem 2. Let's look ahead at problem 5. Actually, let's do 2 and 4 in this video. Then we'll do 5 and 6 on a different video. So let's look at problem 4, because I had some questions on that one as well. So problem 4, you've got HCl and you've got barium hydroxide. If you're not given a chemical equation and you're asked to do some calculations, make sure you write a balanced chemical equation. This looks like a double displacement reaction because they've got 2 aqueous compounds coming together. How do we know it's aqueous? Well, they talk about the molarity, so it must be a solution. Okay, so we've got an acid solution and base solution coming together. The cations are going to switch places, so that's going to make BaCl2 because my barium ion has a +2 charge, right? So whenever I'm writing out the formula for an ionic compound, I have to consider the ion charges. And then H and OH combine to make water. So 1H, 1OH makes water. This is a liquid. Based on my solubility rules, I know chloride compounds are generally soluble unless they're with silver, lead, or mercury, so this is going to be aqueous. Right now it's not balanced. I need to put a 2 right here, and then I'm going to put a 2 right there, and now it's balanced. Okay, so now let's see what I want to know. I want to find volume of HCl, okay, and I know some information about barium hydroxide. So whenever doing some stoichiometry, first step is always find moles. So I'm going to find my moles of barium hydroxide by taking my volume times my molarity. And that gives me moles barium hydroxide. Let me check my calculator real quick. So if I do that, that gives me 0.00300 moles barium hydroxide. And then I'm trying to find something about HCl, so I'm going to use my mole ratio. So first step, find moles. Second step, use your mole ratio. So for every 1 barium hydroxide, I need 2 HCl's. So if I stop and solve there, I find I have 0.00600 moles HCl. And then I want to find volume. So molarity is moles per liter. So let's rearrange this to solve for liters. So if I rearrange it, liters is moles divided by molarity. So I have 0.0060 moles HCl divided by 0.150 molarity. Remember, molarity is moles per liter, so you can see how my answer is going to be in liters. So this is 0.040 liters, which is 40 milliliters. All right, and we'll do another video for 5 and 6.